All right, so this is the lab for chapter 11. This is part one. So I'm going to be doing everything in this. This is all still very new. And then hopefully by part two, you're able to at least start the problems. But at this point, I'm really only expecting that you've read through the first page or so of of the chapter 11 lab. And I don't expect that you've done any parts of the problems. That's what we're doing here today. So if you haven't read anything, go ahead and go back and read about the serial problem that we're going to do. But if you are ready, then here we go. So we are on page, oops, let's see, 112. And what we're going to do is we're going to talk about the chi-squared test for one-way tables, which is goodness of fit. So this is brand new. This is chapter 11. And what you're going to see with chi-squared tests or goodness of fit tests, both names are appropriate to describe this. What you're going to see is it's similar to the hypothesis test. In fact, this is a version of a hypothesis test. However, we will be using a different table. Now, for this, you do not need a table. I will tell you everything you need unless may already be stated in the problem. However, the table is located in the chapter 11 notes PDF and on the last page, and you will see that being used in the chapter 11 notes lecture. Okay, so what we're seeing here is there's a question. Based on your family's experience with this box of cereal, would you likely purchase this cereal again? Yes, no, or maybe. So there's three answers. Before, with the hypothesis testing, do you like Diet Coke? Yes or no. We were not allowing for the option of maybe. But now we're going to see problems that have multiple different proportions or averages that we're going to be using. So in this problem, we have the three choices, and it gives us the percentage of people that have answered. So 65% said yes, 25% said no, and 10% said maybe. And this is going to be important. Those numbers right there, the 65, 25, and 10, those numbers are going to be used throughout this problem. All right, so like I said, you should have already read through this. I'm just going to talk through a little bit at the beginning. And if at any point I'm going too fast through the words, just pause it, read it at your own speed, and then jump back on. So here it says the analysis of some categorical variables requires inference techniques that have not been discussed in previous models. So not exactly chapter 9. Not exactly chapter 9. We will be, you'll see, look at null hypothesis. You're going to see words that you know, but it's not exactly chapter 9. So this is the chi-squared goodness of fit test. And you're going to see me writing chi later. And it looks like, well, let me circle the whole thing because that square matters also. But this chi-squared, the symbol is chi-squared. So it's not an X, because that's an X. It's kind of a little fancy X. It's a Greek letter chi. You're going to see it printed definitely when you get to the table in the chapter notes. Okay, so it says right here, the mechanics are very similar to the hypothesis test, but we will be using a different table. And it's actually, some of it's a little simplified because, for example, these are only right-tailed tests, which you'll see as we go on. Okay, so here we have the null hypothesis. And the null hypothesis is going to have, in this case, three parts. So for example, actually, we're going to write out exactly what this is in the next step. So I will write out exactly the null hypothesis for this part, but we have the very specific details of the basic study that we're looking at. That will be our null hypothesis. And then the alternative hypothesis basically will say something like the null is not true. If our null hypothesis says everything is the same, then our null would be, well, something is different. So our null is what was given in the problem, and the alternative is just saying that that might not be true. Okay, so in this problem, Now they say to use these symbols right here, pi of no. We'll use it just to not be confusing at the moment, but I'm not using those symbols in the future in the notes section, but that's okay, we can use it now. But here we're gonna have pi yes. So the proportion of people that said yes was 65. This is coming from those important numbers that I told you about right here. I put a little box around it. Yes, 65%. So pi no is going to be 0.25 because it's 25%. And the last one, the maybe, will be 10%. So this is exact, I'll make it a 10 just so it looks, it's the same, but that way it looks like the other numbers. So this is what the problem says. The problem says 60% or 65% said yes, 25% said no, and 10% said maybe. So that is our null hypothesis. A very simple way to write the alternative, just pick one from this list above. I can just say, oopsies, the null is not true. In class, we're going to be doing a lot more where everything is equal. That's more common. So then our null would be something like everything is the same, everything is equal, and then the alternative would be at least one is different, something along those lines. But for this example, we have the specifics of the problem, 65, 25, and 10%, and then we have the alternative, and that's just that those numbers are not true. Okay, so for the conditions, there's pretty simple conditions. Random sample, okay, that's what we always want. And then the expected count is 5 or greater. So what we are expecting will be 5 or more. And we've talked about this before. If you just go ask your friends, you ask 4 people their opinion, that's not really enough to sway a vote or sway any sort of campaign. So we need at least 5 people in each expected count. So what does that mean? Well, in the case of the serial feedback, would a random sample of 205 satisfy the conditions? So first off, it said random. So that is a big check. If I could spell random, that would be even better. Random, yes. So then the other one would be greater than 5. Well, I'm not looking at the N. I'm not looking at, I will use the N, but that's not what I'm, because if it was that, it'd be really easy. I'd just say, yeah, bigger than 5, I'm done. What I'm looking at is the expected value. So we need to check that. So we have yes, which was 65%, no, which was 25%, and maybe, which was 10%. So now the question is, what is, so the expected is going to be 65% of our N. How many people is 65% of 205? How many people is 25% of 205? How many people is 10% of 205? So we're going to do that, and we're going to see, you can put it in your calculator, and I'm not really concerned about rounding here because it just needs to be bigger than 5. 133 is bigger than 5. So if you just had 133, that's enough to say that we are greater than 5. 25% is 51.3, and 10% is 20.5. Are these numbers greater than 5? Yes. All, so I should put all the expected values are all greater than 5. So in this example, random, yes. 205 customers, we checked all the percentages. Yes, that's all greater than 5. Okay, so let's try that same thing again with 45 customers. So 45 customers, is that enough? And those of you that are quick with multiplying by 10 are going to quickly see that 10% of 46 is 4.6, which is less than 5. So the answer is no. This is not, it is random, but it is no because it's not greater than 5. You could check all of them, it doesn't matter. You just need one of them to be smaller than 5 in order for it to fail. So this does not work for this type of testing. It does not meet the requirements for a chi-squared goodness of fit test because 10% is not greater than, 10% of 46 is not greater than 5. All right, so now that you have an idea of the requirements, we've already written out our hypotheses. We have our null and our alternative. Now we're going to go to the table on number 5, or the chart, I mean, and we are going to calculate or compute, either way, the chi-squared test statistic. We want to calculate, or compute. I'm emphasizing the verbs there because my point is this is the one we have to figure out with the numbers. And the other one that we're going to be looking at, the critical value, is going to be from the table. Just like before, the test statistic we compute or calculate. The critical value is from the table. Okay, so just as a reminder from a few minutes ago, yes was 65%, no was 25%, and maybe was 10%. So the first, and this table is pretty much filled in. A lot of it's already filled in for you. But the first one, they'll always give you the observed count from the sample. So we have those 3 numbers in the top row. The second row is the expected count. And so we did not have to, let's see, it's already done here. We did not have to calculate it, but since the count was 558, what they did was they did 10% of 558, and they did 25% of 558. That's kind of messy, so I'm going to write it off to the side. What I need now is 65% of 558. So you're going to put that into your calculator, and that answer is going to go right there in that box. So we want 65% of 558, and I'm typing that in. I get 362.7. So right away, we have our random sample, all of our expected, so this is expected with the E, all of our expected values are greater than 5, so this meets the criteria. Okay, so next step, and right here, well, it says step 1. I guess we're at step 0. But for the following boxes on the tables, in fact, all the way through step 4, they write out the operations in words. So observed count, step 1, observed count minus expected count. And in the notes, I just abbreviate this as O minus E, just taking the first letter of each name. Okay, so observed is the top row, expected is the second row. So they already did some for you. The way these were calculated was the top row minus the second row, and that gave us a negative 7.8. These are going to not really fit in here in just a minute. So what I'm going to do to get this box that's missing is the top row, the 382, plus the minus the 362.7, O minus E. And hopefully your pencil's a little thinner. This is a really fat pen that I'm writing with. But you'll be able to write that in and make it a little closer. But when I do that subtraction, I got positive 19.3. So the other 2 answers that were typed in already, those were negative. My answer was positive, and that's okay. All that means is the top row is bigger than the second row. And under the yes category, the top row is bigger than the second row. In the no and maybe, look at that, it's flip-flopped. Smaller, bigger, smaller, bigger. So those two answers turned out to be negative because we took a smaller number and subtracted from a bigger number. That's all that means. It's no big deal. In fact, this is what's really nice. If you mess it up and you subtract in the wrong order, you're still going to get the right answer because the next step is to square it. So observed minus expected, so answer from before squared. My dog is like super excited right now. Okay, we're going to square the answer from above. So 19.2 squared, or not 19.2, 19.3 squared is 372.49. Perfect. Now, the only way you could hurt yourself on this problem is if you type it in your calculator wrong. If you type in negative 11.5 squared like that, you will get the wrong answer. I'm doing it right now and I'm getting negative 132.25. That is wrong. A negative number squared is always a positive. So make sure you have your parentheses, or just type in the positive number every time. Just do 11.5 squared. And either way, you should end up with 132 positive 0.25. So that answer, that's the only thing. I don't care what's going on step one, that row for step one, that step two row has to be positive. All right, last but not least, I'm going to take that number that I just wrote and I'm going to divide it by E, by the expected. Now, what's the expected? This row right here, the one that I did in red, is the expected row. So each row will have a different number in it for the denominator. So I'm going to write that out, and I'm not going to be able to write the division and the answer. So I'm just going to write the division, and when we get the answer, we'll put it down here in step 4 because that's where it's going to ultimately go. So the division you're doing is 372, I'll just write it, 372.49 divided by E, 362.7. I hope you're writing as I'm talking because, see, that happens. I mess up and then it's either hard to read or I erase too much. All right, next row. Take the 132.25 from above and divide it by E. In this row, in this column, E is 139.5. And finally, the answer from above, 60.84 divided by E, 55.8. These will all be positive because we're only talking about positive numbers. Okay, so these answers, yes, no, maybe. Those answers are going to go right in that little addition blank problem we have right there. So 372.49 divided by 362.7 is approximately 1.027. No, I'm kind of cheating, like looking ahead at the answer. The answer is to 3 decimal places, so I thought that would be a good place to round. All right, 132.25 divided by 139.5 is 0.948. And then finally, 60.84, let's typed it in wrong, divided by 55.8 is 1.09. And I guess another 0 at the end, so I don't really need to write it, but it would be a 0. So to double check, we add those 3 green numbers up and you will get this final answer, 30.65. And then let me just, I wrote on it accidentally. That's yes. So what we have is the chi-squared test statistic is 30.65. All right, so that was a lot of calculations, and most likely you just kind of followed along with what I did, and it was a little overwhelming, but this is the first problem, and there's going to be 4 videos, so there will be plenty of time to do this chart over and over again with different problems to get the hang of it. But everything that we did, every step that we worked out was typed up over here. All that typed up stuff explained every step that we did. So you may need to hang on to this at first, but then you'll kind of get the hang of the notation that I use in the notes with the O's and the E's, and be able to figure out these tables. All right, so that is the chi-squared test statistic. So then what we want here, and I don't really want to worry about a p-value. What I wanted to write down here, in fact, forget this. I'm not really worried about that question. What I wanted to talk about here in order for our conclusion is all chi-squared, oopsie, there's no space in all chi-squared tests, I guess there's no D, all chi-square tests are right-tailed. Okay. So again, I'm not really answering the question, I'm just writing a fun fact because we're going to need to use this in order to determine if it is a good number or a good reject region or fail to reject. Okay, so deciding and concluding. Looking here, again, not worried about the p-value, but this right here is the critical value. You'll not be given this, and I will be showing you in a video how to use the table. But what's happening here, again, the 5% significance level, that'll come into play when we use the table. But just using the critical value that they gave, what we have, just like the hypothesis test, is 3.065, our critical value. And then remember, from right tail tests, the right is the reject region and the left is the fail to reject region. So let's look at our number that we calculated. More than 0.2. Oh, I read that wrong. That was the number we just calculated. Look at that. So what sorry about that. That is not what I wanted to say. It was the 0.2 over here that I wanted to put. Okay, so again, this is a little confusing right now because I messed it up, but the reason I messed it up is because we're going to typically do this from the table. I just didn't have the table handy, and anyways, I will be a lot more clear in the next video, but let's just go through the steps with that 0.2. So what was it? 3.065. 3.065 is right there in the reject region. So to conclude, conclusion, we are rejecting it. So there is not, we're going to write a conclusion very similar to chapter 9. There is not sufficient evidence to conclude that, and what was our alternative? Going back, the null is not true. Now, this is where English majors get mad at me, but it's just clunky. That is not true. Yes, there's two names. Yes, I want it that way. This is the alternative. Or we could, I forget how I said it in chapter 9. There is not sufficient evidence to support the claim that, however we worded it. But saying something is not true is not saying something is true. Yeah. Okay, there we go. I said it. I meant it. What do you think about that, English majors? Just because something's not true doesn't mean that it is true. Yeah, so we're going to actually leave it section for this video, And we'll talk about that whole not thing coming up in the future. But for now, I just want to leave it at that. So go back, review any parts of this that didn't make any sense, and remember, this is hour one, video one, whatever time period it takes you to watch this. So it's okay if it's confusing. By the end of the week is when it should start making a lot more sense. So I will see you at the next video.